Hi everyone, so today we are going to be evaluating trig functions graphically. So evaluate just means calculate, right? We're going to be finding a number or a fraction for our trig functions like sine, cosine, and tangent, and we're going to be doing so by using a graph, so graphically. So we're going to be using sine, cosine, and tangent, and just like we learned in our last video, we learned the new way that we can be thinking about this. Instead of using opposite, adjacent, hypotenuse, we're going to be using x, y, and r. So you might remember for sine, right, we would have y over r, right? Sine, I don't know if that's how you remember it, but y over r. Cosine is x over r. And tangent, we didn't really talk about this too much, but tangent is sine theta over cosine theta, right? It's the relationship between sine and cosine, which really means it's going to be y over r divided by x over r, right? Which when you actually do that division, you end up getting y over x, like that. So really, you don't need to remember this part. It might be helpful to remember sine theta over cosine theta later. But for now, we just need to memorize that sine is y over r, cosine is x over r, and tangent is y over x, like that. So those are our original trig functions. We also have their reciprocals. The reciprocal functions are over here. These are cosecant, secant, and cotangent. You may remember these from past math lessons, but essentially they're just the flipped version of their reciprocal function, right? Reciprocal, remember, means flip the fraction. So if I have y over r, then this would be r over y. Cosecant and sine are reciprocals of each other, right? So cosecant goes with sine. I kind of remember this as like, it seems weird that this one starts with the COS and this one starts with the COS, but they actually don't match each other. So I always think like, oh, they don't match. So cosecant must go with sine. The same is true for secant and cosine, which is they are opposites of each other. So this is the reciprocal would be r over x is how we would find our secant. They're reciprocals. And then tangent and cotangent are reciprocals as well. So cotangent would be x over y. Okay. One way that I have learned about this is if you look at the third letter of them, it tells you which one to look at. So secant, cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. I don't know if that'll help you, but maybe that will help you out. Okay. So we're going to be using these 6 functions, the normal ones and the reciprocal ones, in today's lesson. And we'll continue to get good at practicing them. So let's look at example 1. In example 1, it says to use trig functions, so sine, cosine, tangent, to find the given ratio. Assume all triangles are in the first quadrant, right? So that's good information. That means our triangle is going to be over here in quadrant 1, okay? So they tell us the trig function tangent of A is equal to 3 over 7, right? So we want to find sine. So if we know tangent is 3 over 7, they want us to figure out what the other one is, what sine is. So I know tangent is y over x. So I know that y is 3 and x is 7. So I'm going to go ahead and fill that in on my triangle here. My x is 7 and my y is 3. Okay. From there, I know that in order to find sine, I'm going to want y over r. I already have my y of 3, but now I need to know my radius here. So because this is a right triangle, using Pythagorean Theorem, I know 3 squared plus 7 squared must be equal to r squared. So 9 plus 49 would be 58 is the square root. Now go ahead and say, okay, the square root of 58 is my radius, right? Square root of 58 is my radius here. So I know that y is going to be 3 and radius is 58, right? This is essentially my answer. I do need to like break it down. I do need to simplify this and rationalize because I don't want to leave that rational in the denominator. So I'm going to try 58 over here real fast. 50 is 22 and 25, so 58 must be 2 and 29. 29 is a prime number. So there's actually nothing I can take out of there. So I'm just going to go ahead and rationalize. Multiply by square root of 58 on top and on bottom. That's going to leave me with 3 root 58 on the top over 58 on the bottom. Square root of 58 times square root of 58 would equal that 58 there. This would be my answer for the sine of A. Sine of A. Okay. Let's go ahead and try a second one, right? Before we do that, let's just mark out our steps. The first thing that I did was I marked the what letters I knew. The second thing that I did was I marked them on the triangle. The third thing that I did was found Pythagorean theorem to find the third side. And then the fourth thing was once I had all 3 sides, I could go ahead and write my new trig ratio. And then finally, if I needed to, I was going to simplify and rationalize. Right, so those are my 5 steps in the order that I did them. So we're going to replicate those 5 steps on this one here. So first step is to notice what do I have, right? So first step is here. Since this is cosine, might be thinking from earlier, oh, I know that that is x over r. So my x is 1 and my radius is 2. So I'm going to find tangent. Tangent is y and x, so I need to find my y here. So I'm going to use Pythagorean theorem. We have 1 squared plus y squared equals 2 squared. So 4 equals 1 plus y squared. Subtract that 1 over, y squared equals 3. So y equals square root of 3. I'm going to put that square root of 3 right here. That is my y value. So when I find the tangent of y, I know tangent is y over x. So my y is square root of 3, x is 1. I can simplify that to just square root of 3 as my answer. All right. So again, we had those same steps. We had step 1 was figure out what letters they are giving me. Step 2, label your triangle. Step 3, Pythagorean theorem. Step 4, write the new ratio. And step 5, simplify. So same 2 things there. Okay. All right, now we're going to do example 2. We're just going to take it up a notch by moving it out of that first quadrant. So now it says use trig functions to find the given ratio. So same exact instructions. This time it says draw the triangle in the appropriate quadrant. Right, so they're going to give us a clue. I can see that clue is right here on what quadrant to use. So first things first, I'm going to draw the right triangle. So since this is 270 to 360, remember I have 0, 90, 180, 270, and then back to 360. So it's going to be here. So I'm going to go ahead and draw that triangle right there. And now I'll zoom in. So they want us to find tangent, and they're telling us what cosine is. Remember, cosine is x over r. So same steps, right? Here's that first step. I'm going to label x as 1 and radius as 4, right? And I need, for tangent, I'm going to need y. So I'm going to use Pythagorean theorem, same next step. Pythagorean theorem would be 1 squared plus y squared equals 4 squared. So 16, 1, y squared. Move that 1 over here. Y squared is square root of 15, which would mean y is square root of 15, right? So I have square root of 15 here. Notice one thing, since it is y and it's headed down, right? It's in the downward direction. It's not just going to be square root of 15. It's actually going to be negative square root of 15, right? So something to keep track of here. So now I have all 3 sides, so I can find my what they want. So tangent is y over x, right? So I want y over x. Y in this case is negative square root 15. over x, which is 1. So that simplifies to negative square root of 15. 15 does not break down, it's 3 and 5, so I can't simplify that anymore. Sorry about that. So this would be my answer for that problem. Right, just like that. Cool. So same exact steps as you noticed, right? We just had to draw the triangle in a different place. Go ahead and pause the video and try this one on your own, see if you can get it, and then when we come back, I'll show you what we did. All right, welcome back. So I wanted to make a point here, which is that tangent theta is 7 over 24. But based off of the quadrant that they put us in, I actually know that x and y are both negative. The reason I know that is because this is the negative side of the x-axis as well as the negative side of the y-axis. It still works because if both of those were negative, we wouldn't write them, right? They would cancel each other out, but just something to be mindful of as you're drawing your triangle, okay? Once you know that this is like this, you should be able to identify that this is a 7, 24, 25 triangle. So this radius here is 25. If you don't know that, you can still always use Pythagorean theorem. 7 squared plus 24 squared would be equal to radius squared. You'll get 625. Take the square root, which is 25. Okay. From there, they want us to find sine. Remember, sine is y over r. So we would have y, which is negative 7 over r 25. So this would be the answer for this question. Hopefully you got at least part of the question right. Good job. Okay, we're going to do 2 more examples. We might not get to them in class, so you'll have the video. So here we go. So find cosecant this time if cosine is negative 7 or negative 6 over 7, and the triangle is in 90 to 180, the second quadrant here. So here's my triangle. I know cosine is x over r. I know radius cannot be negative, so the negative must apply to the x, negative 6, which is good because I'm on the negative side here. R is 7. And then I want to go ahead and use Pythagorean theorem. So negative 6 squared, or just 6 squared plus y squared equals 7 squared. This is 49, 36. Subtract that 36 over, y squared is equal to 13. Take the square root, we get y equals square root 13. Take a moment to think, is it positive or negative? I know that it's positive because it's on the positive side of the x-axis here. So that is my y. They want me to find cosecant. Remember, cosecant is the opposite of sine, right? So this is the opposite of sine. Sine is y over r. So cosecant must be r over y, right? So you can memorize them if you want. For me, I always think about what the reciprocal is and then just flip it over. So r is 7, y is square root of 13. So I know that I can't leave a square root on the bottom. So I'm going to go ahead and rationalize. So I get 7 square root 13 over 13, like that. 13 is a prime number, so I know there's no simplification to be done. This is my final answer for this one. Okay. All right, a very similar problem. I want you to try it on your own. Go ahead and find cotangent if cosecant is this. At least draw your triangle. At least draw your triangle. We'll be back in just a second. Okay, so cosecant, I know it's the opposite of sine. Sine is y over r. So cosecant must be r over y. R over y. Notice I put it over 1 in order to make it a fraction. Any number over 1 is the same number. So my radius will be 2 and my y will be positive 1. So it's in this quadrant since it's from 90 to 180. I'm going to put my 1 over here. My radius is 2, like so. I'm going to need to find out what x is. I have 1 squared plus x squared equals 2 squared, 4 and 1. Subtract that 1 over, you get 3 equals x squared. Square root is x equals square root of 3. So I'm going to have square root 3 here. Take a moment, think, is it positive or negative? I know that it's negative because it's on this side right there. So I have my triangle set up using the information that they gave me. And now I want cotangent. I'm thinking, okay, cotangent is the opposite of tangent, right? Tangent is y over x. So cotangent would be x over y, right? My x in this case is negative square root 3. My y is 1. I can simplify that to just negative square root of 3. And that is my final solution for this problem. Y'all are going to be great. Ask any questions that you have, and I'm happy to stick around. Okay, bye, y'all.